I think so. Also, you should have written to
Right.
okay, y is equal to the inverse of cosine x. Find y from derivative of y. This is the same thing as x equals cosine of y. So d dx of x equal cosine of y is 1 equal negative sine of y dy dx. Therefore, dy dx dx is equal to negative 1 over sine of y. Recall that cosine square of y plus sine square of y is equal to 1. We can use that so that we can get the expression cosine of y to get rid of sine of y right here. So sine of y is equal to positive or negative square root of 1 minus cosine square of y. You can substitute cosine square of y by x. And then we're going to try to find out if it's the positive or negative sign that applies in this case. And you have to make the graph of cosine.
Not if you want. It's up to you.
Okay.
I did a graph of cosine. Yeah, I tell you what, why don't you go ahead and do it so you can see exactly what is the domain of the cosine. Because that determines whether you take the positive or the negative behavior.
Okay, from this graph, we can conclude that the cosine function is invertible from 0 to pi in this section right here, because it passes the horizontal test. And sine of y is positive that interval.
First, let's say the problem.
Therefore, dx of inverse of cosine of x is equal to 1 over negative 1 over square root of 1 minus x squared.
Yes.
Do you want a second one or just that one?
I'm sorry?
Do you want another one or just this one?
Go for it. If you still have the stamina, start another page. You do it as well as it can be done.
Okay, this time I'll find out that I'll use y equal inverse of cotangent of x. Y equal inverse of the cotangent of x is the same thing as x equals tangent of y. G dx of x equal cotangent of y means 1 equals negative cosecant square of y dy dx. And therefore, dy dx is equal to negative 1 over cosecant square of y. Recall that 1 plus cotangent square of y is equal to cosecant square of y. And all we have to do is to substitute cotangent square of y by x squared. Cosecant square of y equals 1 plus x squared. And we can conclude that dx of cotangent inverse of the cotangent of x is equal to negative 1 over 1 plus x squared.
Great. So if you place now side by side the derivative of the inverse sine and next to it the derivative of the inverse cosine, when you do the same thing side by side, the derivative of the inverse tangent and the derivative of the inverse cotangent, you see that they are the same. The difference is one has the inverse cosine as a negative sign in front, the inverse cotangent as a negative sign. Go ahead and write it down in the summary. If you want to write all four side by side, the inverse sine and the inverse cosine. As I would have done that, as I would like to do it. So you say to the order.
Okay, I want to start by the sine, inverse of sine. Can I leave 2 words?
Yeah. Very good. And the same with the
this one. Oh, this one.
Yeah, what did you do?
Thank you.
I love it when you do my work. You give it to me. All right, so side by side, all left is the original, the cosecant, the inverse cosecant derivative of the inverse secant, but we leave it to somebody else. All right, so, or maybe eventually I'll show you that, but thank you so much. I'm sorry?
I have some problem. I got here and there.
And then to decide what interval to use. All right. Yeah, that's you tackled the issue of the interval very nicely, actually, because that's a sticky point. Why we choose just the positive square root rather than the negative? Sometimes, even in literature, in the textbook, it doesn't. There is no explanation. But you did very nice. Thank you so much.